Hello friends, welcome back to my channel. Today we are going to solve 63rd question from GATE 2022. This is a linear programming problem. We have to find out optimal value of given linear programming problem. The problem is maximize 6x1 plus 5x2 with subject to constraints 3x1 plus twice x2 less equal 12 and minus x1 plus x2 less equal 1 where x1 x2 are non-negative. Now we can see the lines arising from the equations arising from these two constraints are easy enough to draw, and if we draw them in the same graph, the graph won't be complicated, so we can solve this question by graphical method. Now the first constraint, convert it into equality. We get 3x1 plus twice x2 is equal to 12. Let us draw this line on graph. So if we got any 2 points that lie on this line, then we can easily draw a line. Now if we put x2 0, then x1 will be 4, right? So the point 4 0 lies on this line. This is the point. Next, if we put x1 equal to 2, then we get 6 plus twice x2 is equal to 12. This implies twice x2 is equal to 6. This implies x2 is equal to 3. So the point 2 3 lies on this line. Let's draw this. So this is the point 2 3. Now just join these 2 points by a line. Okay, so this is our first constraint. Now second constraint is minus x1 plus x2 less equal 1. Again convert it into an equation, we get equal to 1. So the difference between x2 and x1 is 1. x2 minus x1 is 1. So clearly the line contains 1 0, 2 1, 3 2, like that, because x2 equal to x1 plus 1. x2 is 1 greater than x1. So this is our line corresponding to the second constraint. Okay, now we have to find the region. Now for first constraint, this should be less equal 12. So for finding out exactly which side is gonna be this less equal side, just check for 0 0 point. Now put 0 0 in this equation, we get 3 into 0 plus 2 into 0, it's 0, and clearly 0 is strictly less than 12, so 0 lies below the line. So for first constraint, 0 is on this side, so it will be like that, this side we want, right? Okay, again for second line, do the same thing, put 0 0 here, we have 0. So this is also strictly less than 1. So 0 lies below the second line as well. So it will be something like that. So for both lines, the common region will be this. And since both the variables are positive, non-negative, this will be our region. Okay, now let's find the extreme points. Extreme points will be this point, and this point. Now what is this point? We already know this is 2 3. This is 4 0 and this one is 0 1. Now let's check the value of this function that we want to maximize at these points. Let z of xy, this is equal, okay, z of x1 x2 is equal to 6x1 plus 5x2. Now z of 0 1 is 5, z of 2 3 is equal to 6 into 2 plus 5 into 3, 12 plus 15, this is 27, and z of 4 0 is equal to 6 into 4 plus 0, which is equal to 24. So the maximum value is 27, right? So therefore the optimal value is 27 and it is achieved at this point 2 3. So we just need to write this value, not at what point we got that value. So we need to write only the value. So 27 is the optimal value for given linear programming problem. I hope you all understood this solution. See you in the next video. Thank you.